Hello, everyone. Welcome to Module 7. This is the sustainability module of the course. And the first part of this module is focused on environmental sustainability. The following two parts will focus on the social responsibility and fair labor part of the supply chain and considerations. And then the third part will be a bit of a deeper dive into the topics of degrowth or rethinking growth, along with circularity, which are intertwined concepts, and are sort of more broadly applicable across the supply chain and the industry. But on the environmental sustainability front, this is really my area of expertise. I've been in this field for about 15 years in the apparel and outdoor industry. And I could teach a whole course, and I do actually have in the past taught whole courses on this topic. So tried to condense some of the highlights into this lecture here, but hopefully you'll have the opportunity to dig a bit deeper into some of these concepts through the readings and perhaps even outside of class if you're interested in this topic. There's plenty of different jobs available in the industry on this, and more being added every day and every year, it seems. And just lots of opportunity for growth, continued growth in this area. So the agenda for this lecture is I'll really share some high-level information about climate impacts in the outdoor apparel and footwear supply chain, specific to material choices as well as to facility-level impacts. I'll talk a bit about environmental impact areas other than climate and greenhouse gas emissions specifically. I'll speak a bit about some other supply chain impacts beyond just what's directly happening in materials and facilities within the supply chain. I will provide a few examples of some trade-offs. Throughout the topic of sustainability, there's never what we would call a silver bullet solution, or rarely a silver bullet solution. I think most of the time, as sustainability practitioners, we're always weighing, the effects that one decision will have on perhaps another impact area. And so it's just, it's a very nuanced area. It's often gray. There's not a lot of black and white. And so just wanted to provide a few examples of that and what we face, in the real industry, the real world, so to speak, on a daily basis. And then just a quick overview of the Higg Index, which is a key suite of tools that are used for environmental as well as social sustainability and monitoring in the outdoor and broader apparel sector. So this is a photo I took on a factory visit in China some years ago, probably getting close to 10 years ago now. And I like to use this photo to tee up the fact that outdoor supply chains and broader apparel industry supply chains are really one and the same thing. They're all intertwined. So on the left of this photo, you see a red shirt, and that's an REI camp shirt. And then on the right side of this photo is a dress. I think the brand was Carolina Herrera. And both of these items were being made, cut and sewn in the same factory. And this is very common across the industry. Certainly there are some performance fabrics that are going to be, quite specific to outdoor and athletic, but really for the most part, whether it's more of a fashion oriented brand or more of an outdoor brand, the lines between those two are really getting blurry these days. And historically, and even up to today, much of these products are made in the same facilities. So just to say, when we talk about supply chain impacts, we're really talking more broadly about apparel and footwear industry supply chain impacts overall, of which outdoor is, of course, a part of that. But you really can't separate outdoor from the rest of the, the broader industry in these discussions. So just to give a sense of the scale of the contribution of the apparel, textile, footwear sector to global greenhouse gas emissions or climate impacts, to say that in another way, a number of studies have been done that have tried to create estimates around this, what is the global apparel industry's contribution to global climate impacts. And the estimates vary, of course. It's a real challenge to get our arms around exactly what do we mean when we talk about the apparel and textile sector. Does it include footwear? Does it include home textiles? Many of those fabrics and materials are made in the same facilities as fabrics and materials that go into apparel products. What different data is being used to calculate the impacts. There are so many different variables, but as you can see here, the estimates of that contribution to global climate impacts range from around 2% to around 6.7% throughout several reports that have been done from 2017 up to 2020. And there'll be more reports to come and updates to these, refinement of the data, additional attempts at this. But it gives you a sense overall that, the global apparel and textile sector is not insignificant in terms of overall impact, contribution to global climate impacts. So just a very quick primer on carbon accounting or greenhouse gas emissions accounting in the supply chain. So this diagram is from the Greenhouse Gas Protocol, which is really the primary reference that the apparel industry, including the outdoor and athletic sector, uses to ensure we're all calculating the impacts, the greenhouse gas or climate impacts of our businesses in the same way, using the same methodology. And the Greenhouse Gas Protocol states that there are 3 different scopes of impacts. So scope 1 is the direct impacts that are being caused by your company's facilities or your company's owned vehicles. So this would be thinking about energy use at a company's home office, for example. Scope 2 is the indirect impacts that a company is having. So that's all of the purchased electricity, purchased energy, heating and cooling, et cetera. Again, for the own use, for the direct use, ultimately, of the company. So that would be like a company's Xcel Energy bills, for example, from their owned facilities, or the fuel that they're using to power their owned company vehicles. Scope 3 is also indirect impacts, but it's basically looking at everything else. So that's looking at everything that's happening throughout the supply chain, materials, how materials are being sourced, how they're being produced, how products are being produced, how those products are transported, and then everything as well as, through to employee commuting, leased assets from a company, consumer use of products, end of life of those products, basically everything else that doesn't involve a company's owned and operated facilities. And as you can imagine, for the apparel and textile sector and for the outdoor industry specifically, scope 3 is the vast majority, is where the vast majority of impacts for the businesses in our industry are occurring. So this is a good sort of summary and this was from the Roadmap to Net Zero report that we often use as a reference point in the industry. It was created by World Resources Institute, WRI, and AII, Apparel Impact Institute. And it basically looked at about 30 companies who have approved science-based targets. And I'll talk about science-based targets in a moment, but that's really the using the Greenhouse Gas Protocol, the methodology that's been put into place not only for the apparel and textile sector globally, but also for other sectors globally, like food and the building sector and investment sector, and all of the broader sort of business sectors that are in play globally have aligned around using what we call Science-Based Targets Initiative to determine how to set targets in the same way and then ensure we're measuring against those targets in the same way, so that we can really get an understanding of if we are staying, on track to meet the global goals that we need to meet in order to, keep global warming at a manageable level. So for the outdoor industry and for the broader apparel industry overall, in looking at these 30 companies that have approved science-based targets, it averages out to companies that typically having about 96% of their total greenhouse gas impacts are occurring in scope 3. And that tracks with, the individual percentages that I know about and I've heard about from other companies, including my previous employer. Really between about 95 and 99% of companies' climate impacts are happening in that scope 3, which is basically everything that's not associated with your owned and operated sort of office buildings. And what's interesting about that is that it really helps put into perspective, yes, we should absolutely be encouraging, energy efficiency in office buildings where we're operating, but the vast majority of impacts are occurring elsewhere, are occurring particularly in our supply chains. So the right half of this graphic really shows that of that 96% in scope 3, 80% of that 96% can be on average attributed to purchased goods and services, which is basically saying that 80% of that 96% of companies' average emissions, greenhouse gas emissions, can be attributed to the supply chain. So what's happening in the supply chain in terms of how your raw materials are produced, all the way through to how, for example, cotton is spun or knitted or woven, and then any energy use that's used in the machinery that's used to sew the products together or assemble the products as well. So just puts it in a bit of context in terms of where the real impacts are happening. So to dig into that further, of that 80% of what we call purchased goods and services, we dug into that in context of the main tiers of the apparel and footwear supply chain. So working backward, working left to right across the screen, just to provide an orientation on this, tier 4 is really all about raw material extraction. So how is the cotton being grown? How is how are the sheep being raised? What are the emissions associated to raising the sheep that are growing the wool that you're using in your base layers? What sort of feedstocks are being used for the, whether it's virgin or recycled content in the nylon that's used in your backpack. That's what we call tier 4, what we call raw material extraction, the impacts associated with extracting those raw materials. And then tier 3 and tier 2 are really the bulk of the facility level impacts, I would say, from an environmental perspective. So initial raw material processing. So that's, for example, taking that cotton, that raw cotton, and processing it into a yarn that can then be spun into a fabric. So that initial processing into the yarn, for example, is what we consider tier 3 of the supply chain. And then when that yarn is knitted or woven into a fabric, that's material production, and that's tier 2. And that's actually, as you can see here, the greatest driver of greenhouse gas emissions across the supply chain for apparel and footwear companies. 52% estimated of the overall, again, purchased goods and services impacts can be attributed to material production. And then finished production assembly, only 9% of greenhouse gas emissions are estimated to come from that tier. However, as you'll see in part 2 of this module, that is where a lot of the social, labor, human rights impacts come in as well. And so we really need to be thoughtful about those types of impacts as well. And you'll learn more about that in the next part. But this is a good orientation to kind of where the impacts are falling. And I'll start by focusing on tier 4 and the raw material extraction and essentially the impact of choices you make around raw materials that are going into outdoor products and how that can affect the climate impacts of your products. So this is also pulled from the Roadmap to Net Zero report. And it really looks at what are the key interventions or what are the key actions that we can take in each of those tiers to reduce greenhouse gas emissions. And so in tier 4, to start, there are 3 key actions that we can take. One of them is what we call maximizing material efficiencies. So that's really just across the board. How can we make sure that we are reducing or eliminating wasted fabric during the production of a product? Or how can we just use less material going into a product overall? So the second intervention here, the second action we can take is really about scaling sustainable materials and practices. And this is what we really focus on at Textile Exchange, at the organization I work for now. And a great example of this is rethinking the way that we do agriculture. So typically, the way that agriculture has developed is that it's mostly sort of on a mass-produced, very extractive type of mentality, increasing quantities of toxic chemistries, pesticides, and fertilizers applied to fields and, mass grazing of sheep and cattle and other ranched animals without sort of any, strategy around rotational grazing or how to do grazing or farming of crop systems like cotton in a way that is in tune with nature. And that's really what we're trying to strive for now with the concept of regenerative agriculture. And it's a really hot topic across the industry. Again, could do a whole course on this, but really the idea is to move away from those extractive agricultural systems and toward systems that are more in tune with nature, that do not use those harmful pesticides and fertilizers, ideally, and that have the opportunity actually to leave systems better than we found them. So leave the environment better than we found it, improve human health and livelihoods, create resilient systems for farmers, really move them away from this sort of risk that they take on today and operating on a shoestring sort of margin, where one bad weather year can really wipe out their entire crop, for example. So lots of potential there for scaling of these types of sustainable practices in terms of the materials that are used in the industry. And then the last piece of this, or the last potential action, is accelerating development of what we call next gen or next generation materials. And that's really looking at some of these innovative new materials that are coming out, whether it's innovative technologies for recycling or whether it's innovation around the materials themselves. There are all sorts of different startups in this space right now that are doing everything from looking at how to turn waste gases into a fabric, to using food waste to create different materials, and all sorts of different concepts. So those are kind of what we think about as the 3 key actions that we can take in what we call tier 4, again, that raw material extraction phase, and how we can reduce greenhouse gas impacts in that phase. So at Textile Exchange, we've actually done some greenhouse gas impact modeling and come up with 3 key levers that we're going to need to pull on in order to achieve the climate targets we need to hit as an industry related to the raw materials that we're using by 2030. So in line with science, we have set a target of 45% greenhouse gas emissions reduction by 2030, again, related specifically to the materials that we're using in the global apparel and footwear industry. And as we've done some modeling on this, this is really an oversimplified diagram, but the key points here are that there are 3 key levers to achieving that 45% reduction target by 2030. The first lever, I'll start in the middle, is really what we consider material substitution. So that's probably the most straightforward of the 3. We usually think about swapping out conventional cotton, conventionally grown cotton, for organic or regenerative cotton, or swapping out virgin polyester for recycled polyester. Those are some really straightforward examples. We know that making those switches brings greenhouse gas emissions reduction. So the message to the industry right now is let's get on with doing that as quickly as possible. Let's make those better alternatives really the norm in the industry. We should not be sourcing material anymore from virgin fossil fuels, for example, for the polyester or nylon that are needed in the industry. We should be sourcing those from recycled sources and increasing the amount of recycled material that we're using in the industry and hopefully get to 100% as soon as possible. The next lever is the innovation gap. And as mentioned earlier, this includes what we call those sort of next generation materials and the potential for those materials to have impact reduction contributions toward our 2030 target. But the innovation gap also includes things that just can't be measured today. So things like regenerative agriculture, we are definitely still evolving how we are able to account for regenerative agriculture practices within greenhouse gas emissions modeling. So this is also just a gap in the sort of science around how we can account for some of these things. And then finally, the third lever, and we'll talk a bit about this as mentioned in part 3 of this module, but it's really what we think about in terms of slow growth. So rethinking the concept of value creation for businesses being tied solely to extracting new materials to make new products, which is the majority of how value is created in the industry today. How do we think about, circular business models, for example, is one part of this, but how do we also just more generally as an industry think about how to create value beyond putting new materials and new products out into the marketplace? So that's an area of much further exploration and acceleration for the industry, and something that we'll cover in part 3 of this module. So just to quickly cover the key material categories for the industry, and these are the key material categories we also focus on at Textile Exchange as well. So polyester, cotton, nylon, also called polyamide in Europe, for example, man-made cellulosics, wool, down, and leather. And then, of course, in the outdoor sector, there's also a whole category of hard goods. So wood, metal, carbon fiber, EVA, and polyurethane, for example, are often used in footwear as well. So not forgetting about those materials as well. However, the vast majority of impacts and volume really for our industry are occurring in these categories that you see on the screen here. So this has been the primary focus for us and for the industry. But yeah, I do want to just recognize that equipment and hard goods are another piece of this. Obviously, hard plastics as well would be part of that. And making sure that we are paying attention to the impacts that are associated with those materials as well. And then I just thought I would quickly show some of the raw materials sustainability standards that exist in the industry. And these are actually the ones that Textile Exchange owns. That's really kind of been our bread and butter, so to speak, as an organization for the last 20 years. There are other organizations that oversee standards as well. FSC is one you might have seen, Forest Stewardship Council. There's FSC certified paper, as well as other sort of pulp-based materials, including man-made cellulosic fibers, which are actually pulp-based as well and are used in the apparel and textile sector. But some of the most common ones here that you see on the screen are the organic content standard, and then I would say also the global recycled standard, as well as the responsible down standard, which was actually co-developed with Outdoor Industry Association and the outdoor industry, given that down is such, an important material to our industry. And the responsible wool standard also had quite a lot of input from the outdoor sector as well. And then just to wrap up on the materials piece specifically, really when we think about kind of where is this part of the industry headed, the best practices or the way that we would frame kind of the future of materials is that ideally they would be circular or regenerative. All materials would be circular or regenerative. So what does this mean? This means we really need to accelerate recycling of materials, specifically moving beyond plastic bottles as inputs to looking at how do we create a truly closed loop where old textiles and clothing are being put back into the, back into the system basically to create new textiles and clothing, and being able to create and keep materials and products in use as long as possible. And where brand new fibers and materials must be sourced, the idea would then be that they're coming from organic or regenerative natural sources. And when we think about this, again, to my comments earlier, this is really the opportunity for natural materials to leave the environment better than they found them, to, essentially the potential of regenerative agriculture practices to sequester carbon in the soil, for example. And this also applies, I would mention, to what we call biosynthetic feedstocks. So sometimes you'll see biosynthetics, particularly in takeout food packaging, is where you see this quite a lot. This is also something that's coming to the apparel and textile space, where a polyester or nylon-like fabric is made actually from a plant-based source or an otherwise natural source. The trick there is that doesn't necessarily mean it's actually lower impact. You also have to understand, how is that feedstock being grown? How is that plant-based source being grown? And then how is that plant-based source being processed to make it into a fabric? So a great example of this is bamboo. You may have seen clothing or bedding or towels that are advertised as being made of bamboo. Bamboo is a renewable resource, so that's great from the sort of feedstock perspective. And there have actually been some lawsuits against some brands for touting bamboo as a more sustainable material source because of how energy intensive and chemical intensive it can be in the processing phase. So being able to actually make bamboo into a textile can be very impactful. So all that to say, our North Star is really thinking about how can we ensure that as many materials as possible are kept in use as long as possible and recycled where possible. And then where we need to supplement, how do we make sure that new materials are being grown using regenerative practices? The last thing I'll just mention is a bit about life cycle assessment. So I'm just going to build this slide out here. So basically, this is the way that we measure the environmental impact of materials and products today. And I won't go into too much detail here, but basically it's looking at the exact environmental impacts of all of the different stages of a product, or in some cases, all of the different elements that went into growing or extracting a raw material that's used in the industry. So it's basically looking at, from the resources that are used all the way to the emissions that are required to make that material or product. What are all of the impacts that are associated, and rolling that up into quantitative numbers, basically, that we can use to start to compare the overall impacts of different products or materials. I'll stop there. It can be a pretty technical topic. There's a lot going on in this space in terms of building out new and better life cycle assessment data to help the industry make more informed decisions about the materials and products, the materials that they're choosing, and then ultimately the products they're creating. So watch that space. Yeah, and these are all of the different sort of categories of impacts that are captured within a typical life cycle assessment methodology. And then just a bit of a treatment of some of the key organizations that are working on climate impacts in Tier 4 in the raw materials phase. Of course, Textile Exchange, that's my organization. There are also a number of fiber-specific organizations. So there's one called Better Cotton Initiative that, of course, looks at cotton growing practices. There's also an organization called Land to Market that many outdoor and apparel companies are engaging with to help embed regenerative practices, particularly in their grazing practices. And then there's also the Sustainable Apparel Coalition, And their specific tool that's relevant to tier 4 and raw materials is the Material Sustainability Index, which is essentially a database of life cycle assessment data on the different raw materials that are often used by the industry. Again, as a way to try to understand the impacts of different choices we might make and make more informed decisions about the lowest impact options. Okay, moving on to supply chain impacts then specifically, where tier 4 is really looking at mostly farming, grazing, and then where are we getting the feedstocks for raw materials? Tiers 3, 2, and 1 are really looking at greenhouse gas impacts related to facilities. So actual sort of buildings and operations and what emissions are required to make fabrics or dye fabrics or make and assemble the products themselves. So again, referencing this chart, in terms of facility level impacts, there are, again, 3 key levers I would mention. One of them is really trying to make those facilities, those factories, as efficient as possible in terms of their energy use. Another big one is really elimination of coal as a fuel source for those factories. And then along with that, ideally shifting to 100% renewable energy being used to power those factories that are, again, producing the materials, perhaps dyeing the materials, weaving or knitting the fabrics, processing the leather hides, processing the wool or down, whatever the case may be, all of the energy use that's associated with the operation of those facilities is what we're focused on improving here. And so just for a bit of treatment on facility level impacts and key organizations, as you heard, or I think you would have watched by now, there's a great interview with Kurt Kipka, who is with the Apparel Impact Institute, and Joyce Choi, who's with the Sustainable Apparel Coalition. And together, their 2 organizations are really the sort of leading organizations for the global apparel and footwear industry related to facility level impacts. And there are a number of other programs and different partnerships and things that are in place in the industry as well. But I would say these are really 2 of the main organizations that are working in this space and really supporting the industry in terms of its greenhouse gas emissions reduction at the factory level. And then the other thing I wanted to highlight here is just that everything I've talked about so far is really related to greenhouse gas emissions reduction or climate impacts, or carbon emissions, said another way. And we really want to make sure we're not losing sight of the interdependency of all of these different impact areas, and that we're not just focusing on climate impacts. There are all sorts of different impacts that are connected in everything that we're doing. And so this is where at Textile Exchange, anyway, we talk about this as a concept we call Climate Plus. So what this means is that, we're certainly focused on climate impacts. That is really a guiding star, or North Star for us as an industry, and with regard to the raw materials we're using in particular. And we also don't want to lose sight of these other really important and interdependent impact areas like soil health and biodiversity in nature, and water, and deforestation, social labor and human rights, animal welfare, all of these other areas that are interconnected with thinking about climate and greenhouse gas impact reduction. So just to kind of bring forth that point as well, just want to make sure that that we're aware that it's not just about carbon impacts or carbon emissions or climate impacts. We're also looking at how do we measure progress, for example, in the impacts of our sourcing operations as an industry on nature, or on deforestation. For example, leather supply chains in Brazil today can have a huge impact on deforestation, with parts of the Amazon being clear cut for raising cattle, for example. And so how do we as an industry make sure we're not involved in those types of issues, and that we're sourcing these materials responsibly wherever they're coming from. So just to touch on a few other important impacts that are relevant really across all supply chain tiers, so tiers 1 through 4. chemicals management, microfiber, what we call fiber fragment shedding, packaging, and waste. And I'll talk about each of these briefly. So chemicals management topics that are really important for the outdoor sector specifically. A couple of key examples include durable water repellents, so what are called PFCs specifically, or per and polyfluorinated chemistries. And those are chemicals that are used for generally for water repellency and stain resistance on particularly on outerwear, but also on, potentially packs, workwear, those types of products. And there's been a huge movement over the last really decade or so to move away from the most harmful versions of durable water repellent chemistry. And there are even some policy initiatives or regulations that are coming out in different areas of the world, including Europe, where they're starting to ban the use of these chemistries. So the challenge here is really, finding alternatives that work as well as traditional durable water repellent chemistries that have been used in the outdoor sector. Another chemistry issue for the outdoor industry is flame retardants. This is particularly relevant to camping tents, but also for the broader apparel sector. This can also be an issue for children's wear, and particularly sleepwear. Often, actually, like children's pajamas, often will be treated with flame retardant chemistries. This is another issue that the outdoor sector, again, with regard to camping tents in particular, has really been an advocate for, in terms of, helping to change some of the regulations that are currently fairly antiquated, and were originally intended to apply to sort of large canvas event tents, but have not, necessarily been updated to be more relevant to lightweight nylon camping tents that are used in the industry. So again, trying to eliminate the use of flame retardant chemistries and work with governments and policymakers to ensure they understand that where these things might be required, it might not actually make sense for certain product categories like camping tents. BPA is another one, bisphenol A. You may have seen this with regard to some like drinking vessel companies, anything that's related to sort of food grade products. This is an issue, and just making sure that BPA is not found in, for example, a plastic Nalgene water bottle. I believe all of Nalgene's bottles are now supposedly BPA free. So, and I know this is something that REI has been pushing for as well in terms of all of the bottle companies that it's selling. And then just dyes in general, just a quick mention of all of the dyes and finishes that are used on apparel today, including in outdoor apparel, have varying levels of toxicity, basically, and varying levels of how they're managed responsibly at different factories. So just another sort of issue to be aware of. Again, could probably teach a whole course on just the chemistry issues related to dyes and finishes in the industry, but encourage you to dig more into that if you're interested. Another topic you've probably heard quite a bit about is microfiber shedding or fiber fragment shedding. This is often discussed in the broader context of plastic pollution or ocean plastics. However, I think the key point to get across here is that this is not just a plastics issue, or not just a, in the directly relevant case of the outdoor industry, this is not just a synthetic or a fibers issue or a polyester issue. This is an issue that is relevant to both synthetic and natural fibers. Studies have shown that fibers are showing up in oceans and waterways, and that are both cellulosic, so from natural sources, as well as from synthetic sources. And the challenge is that even if a cellulosic fiber is shedding off of a garment, it's still carrying those dyes and finishes and other blends of materials. Typically, it's not, most of our apparel today, or our products today, are not just one, only one material. They're not 100% cotton or not 100% wool. They're typically blended with other materials and then, again, dyed for a different color, desired colors, or, finished with different types of treatments to prevent shrinkage, for example. So all of these things mean that basically any fibers that are getting shed off of garments are likely carrying toxic chemistry into our oceans and waterways, which is the challenge. So just some myths and facts here, that you may have heard, just to sort of myth bust. It's not necessarily true that most microplastics or microfibers are coming from textiles. There are also all these other sources as well, including the degradation of, bigger plastic items, for example. Synthetic textiles, the myth that synthetic textiles are releasing more fiber fragments than natural textiles. Again, that's not necessarily a factual statement. Fiber fragmentation can originate from all different types of textiles. And then the myth that fiber fragmentation only occurs while washing our clothes as consumers. And this is another myth to bust and make it clear to folks that, yes, that's one place where fibers can shed, but, also in the initial sort of dyeing and processing of fabrics in the supply chain is another place where fibers can often shed in relatively large quantities, or just abrasion from using our products as well. So it's not just a consumer wash issue. All this to say, this is definitely an issue that the outdoor industry has been working on and is concerned about, and is putting real, investment and energy toward understanding further, and ongoing development of test methods to help, get out in front of ways that we can address, and reduce the amount of fibers that are shedding off of garments, from the design phase forward. But just to provide some broader context about the topic. And then packaging is another sustainability topic that often comes to mind or comes to people's minds when they think about impact reduction. I will just say packaging overall, when compared to the impacts related to extraction of materials, and then the manufacturing of those materials and in the manufacturing of the products, is far greater in terms of impacts than the packaging really is in the grand scheme of things. However, packaging is such a visible piece, particularly to consumers, that it often, gets a lot of attention, and rightfully so. Again, this is something that we can and should be working to improve as an industry. So just to kind of orient to the different types of packaging and the different ways that we can think about impact reduction. Of course, product packaging. So that's something like a plastic poly bag that you might get your jacket or garment shipped in when you order something online. Or, if it's a store, they're likely taking that plastic poly bag off the garment before hanging it on the rack in a retail store. There's also just retail store shopping bags, for example, and other packaging that's provided at a retail store. Often you'll see reusable bags available for purchase at point of sale at retail stores now. That's great. I think in general, as a culture, it's time to extend the idea of, bringing your reusable shopping bags to the grocery store, which is something that's far more common these days. Can we also think about that when we're going and shopping at a North Face store, for example, so that we don't have to, require using a single-use shopping bag. Outer packaging, cardboard and corrugate, of course, this is particularly relevant in, today's culture of ordering most everything online. And then that's actually relevant to shipping as well. So shipping from distribution centers to retail stores, as an example, as well as shipping direct to consumer. And then more broadly, e-commerce packaging as well, which, can include that cardboard, but also could include, things like a mailer that a smaller product might come in. I know Prana for years has used brown paper recyclable mailers, and has tied and secured their products with sort of like a raffia tie, which is great because that really reduces the amount of packaging that's used on products. I will say that the reason that Prana is able to do that is because they have a very manual distribution center system. So they have people in their distribution center manually handling those products and doing that raffia tie and putting them into those mailers. A lot of bigger brands have more of an automated packaging system. And Patagonia actually did a study on this some years ago that's available online on their blog site on the Cleanest Line, assuming they still call their blog site the Cleanest Line, where they basically did a study of trying to get rid of the use of polybags in their distribution center. And what they found was that more product was getting dirty and becoming unsellable than it was worth to try to continue not using polybags. Like basically they were losing so much product that actually had a greater environmental impact than the wins that would have been gained by eliminating the packaging altogether. So even Patagonia, given their distribution center setup, has not been able to eliminate polybags yet from all of their products for just some of these challenging reasons of how distribution centers are working and automated today. So lots of continued opportunity for these types of logistics challenges in the industry as well. And then just a few examples of trade-offs as we wrap up here. One of the biggest sort of questions or most common questions that I get is, what's the difference between a bio-based material versus a biodegradable material versus a compostable material? And I won't necessarily read through this content here. You can pause on the slide if you want to really dig in. But I think the highlights here are that bio-based content is really something that's made from renewable resources instead of from fossil fuels. Biodegradable content is talking about what's the ability of that substance or that material to decompose within a reasonable amount of time. And then compostable is open air degradation of material, typically in an industrial composting facility, though some of the confusion with this one is that this could also include a sort of home composting facility. So what happens when you bury it in your backyard, basically, versus what happens in an optimized industrial composting facility. So there are just some key questions to ask with all of these. Around bio-based, the key questions there are just, what is the material made of and how is it processed? So going back to the bamboo example, yes, bamboo is a bio-based material. It's a rapidly renewable resource, and how is that being processed and what's the greenhouse gas impact or other impact that's related to the processing of that material to make it into a textile or make it into some other material that's being used. Looking directly at the hard life cycle assessment data, the quantitative data, and then looking at what happens at the end of life of a bio-based material as well. I think there's often an assumption that because something is bio-based or quote unquote from a natural source, that it's automatically compostable or biodegradable at the end of its life. And that's not necessarily the case. And often what happens is that bio-based materials end up in recycling streams and contaminate those recycling streams as well. With biodegradable materials, the questions to ask are things like, does it truly go away, or is it just breaking down into a bunch of smaller pieces that the naked eye can't see? How do we compare different test results for biodegradability? How do we ensure that a material is actually going into the end the end location that we're testing against? So there are different tests for what happens when something ends up in the ocean versus what happens when something ends up in a landfill. How do we guarantee that that product is actually ending up where we think it's going to end up and performing the way that we tested it against, basically? And then all sorts of legal claims requirements with the Federal Trade Commission green guides, for example, in the United States around what you can claim or what you can say related to biodegradable materials. And then compostable materials. There's a whole lot of research and sort of papers that have come out from different industrial composters in both the United States and Europe saying that actually compostable, quote unquote, compostable textiles are not optimal feedstocks for their compost systems. What they're really looking for is, carbon rich materials like food waste, like traditional, inputs to composting systems. They don't actually want these sort of engineered to be compostable types of textiles in their systems. And then the other challenge here is just we don't actually, as consumers, have widespread access to industrial composting systems. So one statistic is that in the United States, only 2 to 5% of Americans have access to industrial composting facilities. So is it then really the right choice to focus a ton of time and energy on making a product compostable, when really we should be thinking about keeping that product in use as long as possible, given all of the embedded energy that's already been put into making a material and then into making a product, transporting that product in the first place, all of those things. Just food for thought. And then the last piece on this is just really compostable does equal biodegradable, but biodegradable does not necessarily always equal compostable. And bio-based does not necessarily always equal biodegradable or compostable. And the asterisks there just to say not in all cases, that it may be the case, but it is not necessarily always the case. Okay, and a couple last trade-offs just to think about, do we make choices or design products for environmental impact reduction, or do we make choices and design for end of life and plastic pollution reduction? Those two things are not necessarily one and the same. So if we look at the life cycle assessment data of different materials that we could choose to put into a product, the ones with the lowest impact at the beginning of that sort of product's life may not be the ones that are the best choices from a plastic pollution reduction perspective. So just again, something to think about. A key example here is that natural materials don't always necessarily have lower impacts than synthetic materials. Unfortunately, there are a lot of impacts associated with farming and ranching and and the impacts that animals and crops have on our natural systems. They can be lower impact, and if produced regeneratively, where the evidence is overwhelmingly starting to show that producing in that way does bring lower impacts than sourcing a sort of synthetic material, but that's not always the case. So it's important to look at the data basically, and to make informed decisions and recognize that, again, there's no silver bullet for most of these issues where you're going to have to deal with trade-offs. Every material that we could choose and brings impacts, basically, whether it's natural or synthetic, just as an example. And then another trade-off is really, do we design for the system we want to see, even if it doesn't exist yet? Or do we make choices and design for the system that it exists today and optimize for reduced environmental impacts as much as possible within the reality of the system today? So this is another good example here is just, do you design a product that, is designed to be compostable, knowing that only 2 to 5% of Americans have access to industrial composting facilities. So it's likely that that product's not going to end up in that composting facility. Or do you then design for, choosing the materials that have the lowest impact to start off with, perhaps thinking about how the product could be disassembled, perhaps thinking about how the product could be even more durable so that it would last longer. Again, no right or wrong answers here, just another example of the trade-offs that designers and developers of products in our industry face every day. And then the last slide in this lecture is really just a quick plug or overview of the Higg Index tools. This is a suite of tools that was actually originally heavily developed and influenced by the outdoor industry. So back in sort of 2008, 2009, 2010, the outdoor industry had a tool it had developed called the Eco Index originally that was intended to provide a shared benchmarking and measurement platform related to sustainability of products and facilities. A broader group was formed when Patagonia spoke at a company meeting at Walmart around that same time. And the two decided to forge an unlikely alliance and formed what we now know today as the Sustainable Apparel Coalition. And the Sustainable Apparel Coalition created this suite of tools called the HIG Index and incorporated the original outdoor industry Eco Index as a core component of these tools that have now evolved into, tools that are used by the broader apparel and footwear global sector today. So there's a video that I encourage you all to watch in this part 1 of module 7, as you'll see in Canvas, but really there are product tools that are designed to look at overall impacts of the products that are being developed across the global apparel and footwear industry, facility tools that are in use and really scaled quite broadly today to look at consistent ways to measure impacts that are occurring at the facility level. And then there's also a set of tools to look at brands, the impacts of brands' retail operations, as well as their sort of overall operations and governance and so forth, not necessarily related specifically to a product. So I encourage you to dig into all of these tools as well. These are tools that are actually actively used by brands in the industry today, and again, really have their roots in the outdoor industry with the collective outdoor industry's development of the Eco Index, as well as Patagonia's leadership in founding the Sustainable Apparel Coalition that now houses these tools. So thank you very much.